Hello. Hey, thanks everyone. I'm Sri Harsha, and this is Arun. And we have been hard at work building Stream Analytics Manager for past 1 year. And we are excited to share the details today with you guys. So before going into SAM, our Stream Analytics Manager itself, a little bit of history of streaming at how it works. So we started shipping Storm as our stream processing engine back in late 2013. And later we added Kafka as our enterprise messaging queue early 2017. So we've been shipping Storm and Kafka as our streaming solution for past 3 years. And we've worked on a lot of improvements in Storm itself, Nimbus HA, rolling upgrades, a little bit of work in security as well, windowing, Storm SQL. As well as in Kafka side, we added the security as one of the enterprising features and continue to improve bug fixes and a lot of other improvements to Kafka itself. So by shipping Storm and Kafka for the past 3 years, we learned a lot from our user base, customers, interacting, helping them building their applications, making those applications into production, and whatever the support cases, production issues. So there are a lot of learnings from past 3 years. So all of that learnings, we put our thoughts and kind of vision into building registry and Stream Analytics Manager. And that's a little bit of background about where we are coming from. So before I go into SAM in more detail, Schema registry. Schema registry is a foundational piece for the SAM. In general, Schema registry kind of enables streaming applications or even in batch applications, makes it easier for users to kind of realize how the data being propagated. So what I mean by that is kind of, this kind of a kind of bird's eye view of how the a simple streaming application will look like. You have a producer, like a Kafka producer or Kinesis agents, pushing data into different messaging queues, like Kafka, Kinesis, or even Hub itself. So all of this data going into messaging queue is a byte payload. That means if you're pushing a JSON, it's just going into a byte array into the messaging queue. And the other side of the spectrum, someone who is reading the data doesn't know how this JSON being represented. What is the schema associated with this byte payload? So the schema registry comes into play is kind of define what is this byte payload will look like and kind of individually evolve the producer and consumer stories without kind of tying them together. So that's where the schema registry comes into play, and we kind of utilize that as the foundational piece to build SAM, and I kind of give you more details in the demo, but that's a starting point on how we started our journey towards making streaming applications easier. So again, there's a talk about the schema registry today at 5:50 by Satish. He'll go more details about the schema registry and the vast use cases that it kind of enables, not just the SAM story. So Streaming Analytics Manager. So what we are trying to do here, so a platform to design, develop, and applications to simplify the APIs, kind of provide a UI for the users and developers alike, kind of drag and drop analytics, and you can drag and build these applications, deploy these applications into the production, not only kind of help the developers, but also kind of help the operation side of the things as well. So once you deploy the applications, how are you going to monitor? And that's one aspect of it. And once you actually have a running topology, the data that is being processed by the applications, how are you going to visualize this? How are you going to process that information? So that is togetherness. We are building this. We're coming together. All of these aspects coming together is part of the SAM story. So the guiding principle here is kind of minimize the time it takes for someone's business use case to build and deploy and visualize the story behind it. So that is the Stream Analytics Manager. That's our goal in building this. So streaming is becoming the kind of de facto, like everyone moving from batching to streaming use cases of late. So there are new streaming engines coming every other week, it seems, and there are new APIs that everyone needs to learn. So what we are trying to get away from is kind of with SAM, you have a global API and a global and a UI editor that allows you to run an application irrespective of the streaming engine that you use. So we have a unified API story. On top of that, we have a topology editor. One can visually build a topology and deploy. On the other side of the spectrum is you have engines who is subscribing to this unified API can run your topology. So right now we have Storm integrations, and we are working on Flink and Spark integrations as well. So any streaming applications is not just fulfilled about it doesn't exist in a silo. It's actually interacting with multiple services such as Kafka, Kinesis as a messaging queue, as well as an HBase, HDFS, Hive, or Druid. So in between, you have a process kind of taking this data, doing some interesting things, and getting it stored into different stores. So all of these services right now, when the users actually use Storm or Spark, they have to package all these configurations together. So we are trying to minimize this configuration settings between different services. So we created interesting abstractions around this, kind of service pools and environments. I'll go more deep in demo itself, but that allows users to kind of pack all the necessary configuration together along with your application and deploy in the topology. So the user doesn't need to worry about where my Kafka is running, where my name node is running, where my HBase master is running, etc. Another thing we are looking at is operations. Once you have that application deployed, you need to monitor the applications, how it's doing. If you're ingesting 1 million messages, are they all reaching to your end storage? If there are any issues. So all of this, we are kind of showing the dashboard, exposing the necessary metrics, as well as the application metrics. Along with that, we also are working on adding alerts so that if something goes wrong, the users are getting notified so that they can come and debug that. So some of the key challenges we are looking at is like, make the application build time much more simpler and easier. And again, today with the current APIs, it requires considerable amount of programming, testing, and running in different clusters. So we want to minimize that effort as well. So basically, the idea is kind of minimize, don't worry about all these different APIs. Instead, concentrate on your business idea and make it productionize and deploy and make it working in the production environment. So the idea behind that is the users doesn't need to worry about what is the streaming engine that is running underneath it. Instead, concentrate on the business idea that you're working on. So a little bit about how the layers works in the SAM is we have a distributed streaming computation engine, which could be Storm, Flink, or Spark. On top of that, we have a unified streaming API that we have built, and a stream builder. That is a topology editor. There's a UI builder. So once the user drags and drops, creates a DAG, that's actually converting to a unified streaming API, which eventually get deployed into your engine of choice. So you have the topology that is getting built and getting deployed, and it's processing some data. So within that silo, it doesn't do much unless you visualize the data. That's where the Stream Insight comes into play. So right now, we are using Druid as our storage, so where you can actually write to Druid. And on top of that, Superset is, you can use Superset to visualize the data that is being written to Druid. And all the data that is being written to Druid is in a streaming fashion. That is, as soon as your topology kicks in and events are getting processed, your data will be visible on the Druid side. On the side node is the streaming operations. That is the operations team that is actually monitoring your topology itself. So the Stream Insight, what is the Stream Insight is you have the topology running. You want to kind of understand like what is my, let's say if you're running a store-based application, what are the number of transactions that took place last 5 minutes? So all of this data that is getting processed by your topology can be visible and can be create a dashboard on top of that using a Stream Insight module that we have. So that's, in a nutshell, kind of overview of what we are trying to build. I think my story will be much more easier to tell when I get to the demo. So without wasting much time, I'll start the demo. So this is SAM. So that's a topology listings page. That's the first time that you see. So we have a bunch of applications running. This is kind of a bird's eye view of what's going on in your system. So we have like almost 10 applications running. So you can see this one is already running and kind of shows the most critical metrics by looking at it. That is, I don't have much of latency. I have a bunch of components taking different times and how many workers that I'm running, and et cetera. So before we even go there, what we want to talk about is service pool. So as a streaming applications, you're probably reading from a Kafka topic and doing a window aggregate, joining a bunch of streams and a rules engine, and then you're probably writing to an HBase or a Druid. So all of these configurations together, previously with regular streaming engines, you have to kind of write it out in your code or a config page. You need to figure out where the Druid is running, where your Kafka is running, and all that setting that you have to do manually. With service pools and environments, we're trying to address that problem and make it easier for the users. So what you see here is a bunch of clusters that are already imported. So let me take this out. So what I'm doing here is I have an Ambari cluster running here. So I have a bunch of services like Storm, Kafka, Registry, and Ambari Metrics and Zookeeper running here. So what I'm going to do is use this cluster and import all the configurations that are available in Ambari into SAM itself. So it's went and talked to Ambari and fetched all my configuration into my SAM installation. So in case if you're not using Ambari, we also, all of this is actually pluggable. That is, we have a pluggable way of like replacing your configuration storage. Now, if you don't use Ambari or any other service such as that, or if you're using Puppet and Chef, you can actually create a manual cluster. And go here and select different services that you would like to, and kind of manually add the configurations here. So service pool is actually a one-on-one representation of how your cluster is installed, what are the services you are running, and what are the configurations stored in it. The next level of abstraction we have is environments. In a typical workflow that your application might be, as a developer, you might be running in a staging environment, and once you build it, you probably want to transfer that into a QA environment for testing it with the sample data and everything. Once everything looks good, you want to kind of project this application, deploy on a production cluster. So that's what we have here. So what environment allows us to do is, for example, in this case, I'm creating an environment. So it showcases all the service pools that I created using Ambari or manually. And I can pick and choose what are the services that my application is going to run against. In this case, I'm going to run against Storm here, and I'm going to use Kafka from here. And I want to store the data in HDFS and HBase or Hive. So these are the three components I'm going to use in my application that I'm building right now. So we created a new environment called my demo. So once I go into my application space here, so I'll go create a new. Here I have a choice of different environments that I can choose against to build my application against. So I'm going to use, in this case, prod. So once we associate an environment, so as you can see, I have all the sources and processors and sinks on the sidebar. I'm going to use Kafka. So what it's actually doing here is I create an environment, and I have my clusters imported. So here I can see the cluster names that are available in the environment. And as soon as I pick one, it actually shows me all the Kafka topics that are available right now. So this is already automatically fetched for the user to give the context and what's going on. So another interesting thing here is, so initially I talked about the registry, like the way you kind of express the schemas that are going into a topic. So this Kafka topic as a schema, let me. So here is a registry UI. Again, so there is already a bunch of schemas already set up. So you can see this is the schema name. Schema name needs to match with your Kafka topic name or Kinesis topic name, whatnot. So the schema is already available here. So all the schema that is exposed here will be coming into. Okay. So the schema that we are fetching from the schema registry, as soon as we select the topic, the schema associated with that topic will be appearing here. So this is everything else is the typical Kafka configs. So all the configs are exposed here and how you want to read and everything else. Now I can drag a aggregate processor here, connect into aggregate. The schema that we defined before is actually carried over at each node in your DAG, in your topology DAG. So that gives you contextually on any given node what you're trying to do. So in this case, in this aggregate window, I'm getting all the details here of the event time, all the schema details. So I can select event time, I want to group by based on the driver ID. So this is an aggregate window processor. I want to choose a window interval type of time of, let's say, 5 seconds. You can get to define if it is a sliding window or a tumbling window based on your window configurations here. And timestamp field, you can use processing time. And if you happen to have an event-based time in your schema, you can choose that as well. So on the output side, I have all the fields available right now here. For example, in this case, event. And also, you can, so we are basically what we are defining here is a window processor with a schema and with a window configuration of sliding window or whatnot. And you can actually operate based on your input fields, what are the aggregation that you want to define, right? So in this case, these are all pluggable aggregations as well. That will, Arun will talk more into the details about that. So let me see, I'm creating a simple aggregation. I'm going to create another Kafka here. So I have another topic that has a before going into that, I also have a join processor that can allow me to join 2 different streams. So this will allow me to kind of join one stream based on, let's say, driver ID. I'm going to use inner join and driver ID here. Again, 5 seconds. This will allow me to kind of pick and choose what are the output fields that I would like to select. So we define 2 Kafka sources with 2 different topics, join them using a window-based join, and then I'm going to add an aggregate. So this will give me all the output fields that I selected from the join processor. Here, I'm going to group by driver ID and a window interval of, let's say, 5 seconds. I'm going to use speed and a max. So what I'm trying to do here in aggregate window is like for 5 seconds, for every driver ID, give me the max speed that they are going for. So that's the window I created. So each time when I'm selecting the fields, the output schema getting calculated here. Once I have that, I also have a rules processor. So I'm going to connect my aggregate processor to rule. So the input fields the output fields that we define in the aggregate processor are coming up here. I'm going to use speed max if it is greater than, let's say, 100. I'm going to trigger a condition. So once if that condition met, I'm going to use Druid. So also, as you can see, all the details for the Druid are already filled up. All of this coming from just because we added the service into the environment, and all the metadata being sucked into and displayed here for the configurations. So as a user, you are actually concentrating only on the things that you need. So basically, just to summarize what we did is we had two Kafka streams coming in. We joined together because we had these are the data that we have is a speed events data. There are trucks going in, and the driver information is in one topic, and we have a speed events in another topic. So we joined them, we combined them, then we create a window of, let's say, 5 seconds to kind of calculate the speed, and then we are adding a rule processor to trigger an event based on if the value of the speed is greater than 100. Then we are storing all the data into Druid, and once the data gets into Druid, we can use Superset to kind of create dashboards and visualize the data that is being processed. So essentially, to summarize from the beginning, so as a user, as a developer, I don't need to worry about where my services are running. I just used Ambari to create a service pool. Then I create an environment to talk to multiple clusters that are installed. In one cluster, I have Kafka and Storm running. In another cluster, I have HDFS, HBase, and Druid running. So now I created a topology based on that metadata that I have available. So once I go into the topology editor, all of my configuration is readily available. I need to pick and choose what I need to do and kind of create end-to-end topology within a few minutes right now. So once I click deploy, it gives me the configuration that I want to kind of choose, like if I want more workers. These are all like coming from Storm-related configuration. So if you're running Flink, you will have contextual-based configuration available here. So while deploying application, it's actually pulling all the artifacts that are needed to run this application. That is, what is your Storm Kafka connectors, and also configuration that is getting pulled in from your service pool and getting it deployed into your Storm cluster. So the interesting thing, again, we didn't tell which Storm cluster right now to deploy against. We actually made the decision while creating the environment itself. So it's actually figured out from the environment, since you have a Storm cluster there, I'm going to use that, and I'm going to deploy against it. So the application is deployed. So going back to my applications here. So we hit this. So this is the application that we actually built in SAM, now getting deployed in Storm itself, and you can see the DAG that we just deployed. While we are doing that, while it's trying to run there, so let me show a few things here. So this is the view mode. Takes a few more minutes to get the metrics up and running. So basically, there is editor mode that we actually built the application against. Once we deploy, you also have the view mode. Here you have all the metrics that are Storm and in your application available in the dashboard form. Let me see if there is any other application running. For example, we already have an application that is deployed. So it's actually showing what is your input-output events that are going through, and what is successfully acknowledged tuples and any failed tuples that are thrown through. So we have varied multiple metrics that are available right now, and we're going to extend this dashboard page, allow users to customize the dashboard page of how the operational can look at it running topology. So you can actually create an alert based on number of failed tuples within 5 minutes greater than 1,000, alert my dev team so that they can come and look at the topology, what's going on. So once you have the topology up and running, and once it's processing and everything else, the next stage is basically visualizing the data that you actually getting created by the topology itself. So we already have a trucking IoT demo that is running already. So let me go back. So we have this topology running. It's fairly complex topology that is running and ingesting into Druid. So based on that, we already have, where is? Yeah. So the trucking IoT demo is actually using the same data and creating some violations, alerts, and everything else. So all of that is actually visible in the superset that is being ingested by the topology itself in a real time. So the users actually went ahead and created a bunch of slices here. So you have slices. So this is the data that is being ingested. So as a user, you can actually go and create independent kind of widgets on how the dashboard should look like, right? So for example, if you're interested in last 1 hour, how many violations occurred. So you can go and write some custom query and create a visualization that you want and create a main page of dashboard where you can actually combine all these independent widgets, kind of showcase your application. So from end to end, you actually created a topology that is reading the data from that is going into Kafka, create a aggregate window, and create a custom rule cluster, and then store it into Druid. That's one part of it. The other part is actually realizing the data that is through superset on top of Druid. You can go and customize your dashboard on how you look at this data. So we are addressing the 3 parts, which is the developer side, to make it really easy to build the application itself, and the operation side where you actually visualize the metrics that are happening in topology, how the topology is behaving in production. And on the last part is the business analysis itself. So you have data flowing in, how are you going to kind of visualize the data? That is also available together as a SAM within the SAM itself. So that's the demo. So I'm going to hand it over to Arun. So he will go more deep into how the DAG is performing and how we can hook into different stream processing engines, as well as the extendability. So far I've shown is a building blocks that we are already shipping. And you already might have a question about, like, if I want to add a code, like I want to add my own custom business logic, how do I do that? So Arun will take over from here and he'll get more deep.
Thank you, Harsha. So I'll go over what are the different components in SAM and how they interact with each other, and what are the external systems that it interacts with. And I'll also cover what are the runner interfaces that the streaming engine needs to implement and how we can extend it. So this is a SAM UI that is running in a browser where you dragged and dropped and created the topology. And the SAM application itself is running as a web app in a Jetty container. And all the functionalities of SAM are exposed via REST API so that it's extensible. And as you build the application in the UI, it's calling the different REST APIs. And as you saw in the demo, so when typically start out by building a service pool. So SAM interacts with the environment service module to pull out the service pool information from Ambari. SAM also talks with the schema registry client to pull out the schema info. So this is the schema that comes up when you choose the Kafka topic in the source. And as the topology is being built, all that configuration and the connections are getting saved into a database. And it goes through a pluggable storage manager. And the storage manager is like we support currently MySQL, Postgres, and Phoenix. It's actually pluggable. And now let's see what happens when you deploy the topology. So all this configuration that is stored in the database is pulled out and pulled out by a topology actions service. And it hands it off to another module, topology DAG builder. So this is the one that constructs the DAG, and then that DAG goes into a topology lifecycle manager. So this is a SAM DAG that is being sent to the runner. And below that you have the runner implementation. So right now SAM has a runner for Storm. So the main responsibility of the runner is to translate the SAM DAG into the streaming engine topology. So in the case of Storm runner, it translates it into a Storm topology and deploys it into Storm. So this Storm cluster is where the actual topology is being deployed and executed. And while executing, it may also talk with schema registry to pull the schema information for deserialization and serialization. So if you want additional streaming engines like Flink and Spark, all you have to do is add another runner. So we'll see in the next few slides what are the interfaces that you can implement. I'm going to go over this quickly. So this is a topology state lifecycle. So yeah, the initial state, when you deploy, it constructs a DAG, goes into the DAG constructed state. And then it's actually packaging any extra jars or dependencies. So for instance, if you have a custom processor or a user-defined function, it's packaging all that and goes into the extra jars setup state. And finally, it deploys it in the streaming engine and goes into the deployed state. So if any of the steps fail, it moves into the failed state, from where you can try to redeploy the application. And while it's in a deployed state, it can be suspended, resumed, or killed, and then this cycle continues. So DAG is fairly straightforward. You have a set of sources, process, and sinks. So those are the three main components in SAM, and they are connected via edges. And sources and processes can have one or more output stream. So stream is a logical channel of output and with a defined schema. So for example, in the source, you have a single output stream, stream 1, with fields A and B. And in the case of source, this is actually coming automatically from the schema registry. And as the different processing is done, the schema is being evolved and translated. So this is a runner interface which defines the topology lifecycle. So you have the methods for deploy, kill, suspend, resume, and so on. So each of these methods receive the topology layout, which contains the topology DAG as the input. And within, say, deploy the streaming engine, so this is typically implemented by the runner, and the runner decides what needs to be done to deploy this SAM DAG. And for deploying, for translating the DAG, typically runners implement a visitor. So you visit all the nodes in the DAG with a visitor interface, and you can decide what needs to be done at each component level. So this is going to be called back for each of the source or sink or processor nodes. So in the Storm runner case, so we are actually generating a Storm flux as a final output. So, so for example, when it encounters a source, it sees what kind of source it is. If it's a Kafka source, it generates a code for plugging in a Kafka spout and adds it as a component in the YAML. And in the deploy, we are actually using this flux generator. So we pull out the DAG from the layout, create an instance of the flux generator, and traverse the DAG with the flux generator. And finally, after it traverses all the nodes in the DAG, we have the final flux output, and that is being deployed. So this is equivalent to running a Storm jar command with a flux file, as you do even without SAM. So for a runner interface, typically, if you are implementing another streaming engine, these are the main interfaces that you will have to implement. This has, of course, other methods, which is not shown here. So that is high level about the architecture and the components, and I'll try to quickly cover so Streamline provides standard set of processors and functions. So what if you want to add your own business logic? You want to write some custom logic. So we have a custom processor interface. So basically, this is where you can write your own business logic. So the main method is a process method where you get the input event and you return 0 or more output events. I'll try to show the UI after this presentation if I have time. And so that was in Java. So we also have a multi-lang support that is upcoming. So we have a multi-lang protocol. So basically, any scripting language that implements this protocol can be plugged into SAM. So this is a Python example where it splits a stream of sentences and into stream of words. UDAF, so user-defined aggregate function. So this is basically used in the aggregate processor. So you want to aggregate, compute the average value of some field over the last half an hour or something. So we have a bunch of supported user-defined aggregate function. We'll be adding more in future, but if you want to implement your own custom, this is the interface you can implement. And so user-defined functions does simple transformations. We have a bunch of standard ones, and you can implement more. And there's also a notifier interface. So this is SAM as a notification thing where you can send out alerts. We have a built-in email notifier, and if you want to add a custom one like SMS or something, you can implement the notifier interface. And the current release 0.5 that was announced yesterday, we added a bunch of features. Actually, Harsha covered most of it. The manual service pool, test mode. Actually, we added Kerberos end-to-end. It supports end-to-end Kerberos authentication. There's authorization with role-based access and permissions. And what's upcoming? We are planning to extend the token-based authentication to support other things. And state management, so where you can update a state, use that in your operations and query the state and so on. And support for other streaming engines, like I said. So SAM is open source, so we are also working on it, and we'll be open to contributions. And finally, so try it out. It's under Apache license, and here's a GitHub link. You may want to check it out and send patches and put your, if you find any issues, you can post it there. Incubation, so we are trying to incubate it in future into Apache. And 0.5, that is a release that came out yesterday. There is a discussion group for the user. So contributions are welcome. So thanks a lot for coming. So we can take any questions. We have a couple of minutes.
Cheers.
Yeah, I have two questions. The first question, I just want to confirm SAM interface is like SQL-like. It's pure SQL-like. Looks like it's an aggregate, join, and filter. All the operations user can use from the UI is SQL-like, right? And I'm asking the plan when you translate to the Flink and the Spark is directly to the SQL or is to the transformer lower operator? That's the first question. The second question is, when users start a job, how do you let user configure the results and the parallelism?
Yeah, so let me quickly jump to the second question, which is how do you configure the parallelism and the workers. Where is it? So everything right now is within the UI itself. So you can go to editor. So you have here the numbers. Those are actually the parallelism of the component. And you can also have the topology settings here. You can actually create the workers, increase the workers or whatnot. So that's how you configure the parallelism and the worker units. Coming to the earlier question, which is right now we are translating, for Storm, we are translating that into a flux. The constructs that you see in topology is pretty much like a SQL kind of thingy. So would we in the future, when we support Flink and Spark, would we use SQL? So I think SQL will come into play, but some of these processes that we want to go with is much more, can get complex. And the topology DAG translation is much more flexible, gives us much more future proof. And also, given that the custom process that we talked about, some of the things that, this is a custom processor. So the good thing with the custom processor is once you actually write this code and you go to here in the settings and application resources. So these are all user-defined, or user-uploaded custom process and stuff. So you can go here, the interface that Arun showed. So this is the class that is extending that interface. And these are the configs that the custom processor need in the runtime for the user to pass. And it's also defining an input and output schema. So once you create that and upload that, it will appear in your topology editor. In this case, in here, so let's say, so all the stuff that we actually use at define in the config page is appearing in this dialog box. So dynamically, you are registering a custom processor and everything else. So some of those artifacts that we want to do, probably harder to express in SQL, and DAG translation gives us much more flexibility. So for now, we will be sticking to that. And if you see, if it is easier to do that in SQL, we'll probably use that as well.
And to add to that, in the rules processor, we have a SQL way of filtering out.
That's it? Okay.
Thank you.
Thank you.